Great. Our next big idea here in chapter 7 of Integrated Math 2 is the idea of what we call conditional probability. And conditional probability is obviously related to the idea of probability, but you'll see in a second how it's a slight modification of what we've been doing here in the past. So let's suppose we had a standard deck of cards. And as we all know, there's 52 cards in that deck. So if I said to you, hey, what's the chance of actually getting a king at random? You'd say, well, there's 4 kings, and I know there's 52 cards, so you would say 4 out of 52. So here's where the change happens. What if I said to you, what's the chance that it's a king, given that it's a face card? So what this does is it narrows it down to only the face cards. And face cards, as we know, are either jacks, queens, or kings, and there's 4 of each. So that narrows it down to be 12 possible cards that you could be choosing from. And of those face cards, how many are kings? Well, 4 of them are. So by using the idea of conditional probability, what we do is we impose this condition, and we say it's given whatever that condition is. So now all of a sudden that probability changes from being 4 out of 52 down to being 4 out of 12. So let me give you another example of something you'll see an awful lot in our CPM book, and that is where you're going to be actually given a table. So in this case here, what happened is 300 people were surveyed, and they were asked, hey, what's your hair color and what's your eye color? And so the results were recorded over here. And so we're going to answer these questions over here in a moment here. So you've got this table, and typically what's going to happen is the totals are not given to you. You'll typically see all the numbers are in the middle, but not the totals. In fact, you may not even see a total for the column and a total for the row, but you want to go ahead and include that in there. So I'm going to give you a second right now to go ahead and figure out the totals for all the different ones here along the outside. So go ahead. All right, so now that you've done that, I'm just going to go ahead and fill this in here and make sure we all agree on the answers. So we should have 96, 204. Our grand total is 300, which isn't surprising because that's what we were told at the very beginning. Over here, we have 144, and over here, we have 156. So now we have our totals. So in this case here, if you were just asked, what's the chance that a randomly selected person had blonde hair? You would say, well, first of all, how many people have blonde hair? Well, here's blonde hair, and the total number of people would be 96. So 96 total people have blonde hair, and there's 300 people altogether. If you want, you could go ahead and change it over to a decimal, which is similar to a percent. So that'd be about 32% or about 0.32. So that would be the chance of someone having blonde hair. If you went to brown eyes, you'd say, well, how many people have brown eyes? Well, you go over here, and here's brown eyes. Go down to the bottom. That's the total number of people with brown eyes. So that would be 144 out of 300. And if you do the math on that, that would end up being about 48% or 0.48 as a decimal. So now let's look at conditional probabilities here. What if I said, what's the chance of someone having blonde hair given you know they have brown eyes? So the given narrows things down. So you're not going to look at all 300 people. You're going to look at only the people with brown eyes. So how many people have brown eyes? Once again, the total number of people with brown eyes is 144. So this is going to be out of 144. Now, how many people have both blonde hair and blue eyes? That would be this spot right over here. So of those 144 people, 63 of those people have blonde hair. So I'm going to put 63 up here. And if you do the math on that, that ends up being about 0.438 or close to 44%. Finally, let's reverse a little bit here. What if I said, you know what? They have blonde hair. They don't have brown eyes, but they have blonde hair. Well, now what's the chance of them having brown eyes? So let's do that right here. So how many people have blonde hair? Blonde hair total is 96. So now we're only talking out of 96 people. And of those 96 people, how many of them have brown eyes? So looking at this row right here, how many people have brown eyes is 63. And if you were to take 63 divided by 96, that ends up being 0.656 or really close to 66%. And you'll notice here in both cases, because they're blonde hair and brown eyes, the givens change here, and so is what we're looking for. But you'll notice the top, here's the top, they're the same, and that's the both. Both blonde hair and brown eyes, where the bottom is just how many total given number of people there are. Either brown eyes is 144 or blonde hair is 96. So that's what we call conditional probability.